Hi everyone, welcome to my project work for the 1E5995 course at Wayne State University. So my project is an IoT-based temperature, humidity and air quality monitoring system which utilizes the ESP32 and the BME680 sensor. So the idea behind this project work is to basically make a smart device that can basically measure the temperature, the humidity, and also the air quality indoors, right? And what this also does is that it produces a dashboard which can be accessed if you are in the same network as the device. Additionally, another feature of this particular device is that it's able to log the sensor information onto an SD card so that we can basically do machine learning inference upon the data that is collected. So this is the project title. So for this project, I basically utilized the ESP32 board, which is this board here, as you can see, and also I use a micro SD card reader which is connected to this ESP32 board, and I also have the BME680 sensor here. Now, one interesting thing that I also did for this particular project is that I have an LED bulb connected to the ESP32, which goes on and off, or basically blinks whenever there's a data point stored on the SD card, which is here. So first of all, what I'm going to do is to basically put the SD card inside the SD card reader, which is here, like this. And what I'm going to do here is to basically start my Arduino. So here, this is I'm going to basically start my ESP32 board. So first of all, I'm going to clear this board here and reset. Now, if you can see the screen here, what is happening here is that the Wi-Fi is trying to connect to my network. After it connects to the network, it basically waits for me as a prompt to start the server and also starts the logging of the data. So if I press any key on my keyboard to the serial monitor, like maybe any key, whatever, and I press enter, what is going to happen is that the header file is going to be created, and then the data is going to be written on the SD card, and as the data is written, the light blinks in and out, as you can see here. I think, yes, so I think the light should come on and off as the data is written onto the SD board. Printed out to the serial monitor as well. So the next thing is that I also create a dashboard as well. So for instance, if you go to the IP address, which is 192.168.27, which is basically what is on the Arduino board, which is printed here, then you can also access the dashboard, which shows the temperature, the humidity, the pressure, and the air quality score. Here I have an air quality score of 21%, which is pretty good, and this can be changed periodically as you refresh the board. I think I tried basically to make this more or less automated, but for some reason it wasn't able to work out. But basically, if you refresh the weather station, you get more updated values of the sensor here. With that, I would like to thank Professor Yao Chan Liu for his supervision for this project, and that'll be all. Thank you.